In this video, we're going to learn how to simplify complex fractions. So a complex fraction is really just a complicated fraction. So it's an irrational expression that has at least one fraction in the numerator or denominator or both. So what that means is typically a rational expression is going to have some kind of numerator over the denominator. Now, if we look at this first numerator, it's got two fractions being added together. Or this one has another fraction. Or this one has two fractions being added together. If we look at our denominators, this one has a fraction, this one has another fraction, and this one has two fractions being subtracted from each other. The best thing you can do when you see this, it might look like you have something over something, over something over something, and that can kind of seem tedious or seem scary because it has like three denominators. What you can do is take the first two, call that the numerator, take the second two, call that the denominator. Then it doesn't look so bad. So if you are able to kind of color code it or put parentheses around it, it helps you see what's going on. So remember that all fractions have these invisible parentheses in the numerator and denominator. So what we're going to do is always simplify the top and the bottom before division. So what that means is in this first one, I would add these two together before I even worried about the denominator. So try simplifying your numerators, simplifying your denominators, and then finally you can divide. Same thing is true when we're just working with regular numbers. So in something like this, what we'd have to do, my first step is to focus in on this numerator. Combine the 1/2 plus 1/3. Well, I can give that a common denominator of 6. So this becomes 3/6, and this one becomes 2/6. Now that's all in the denominator, and then I have my numerator and I have my denominator of 1/4 still. Now I'm going to combine 3/6 plus 2/6 is 5/6, all over 1/4. Now, what we do, we have a fraction divided by another fraction. Remember when we divide fractions, we keep, change, flip. So now I can say 5/6, keep it, change to multiplication, flip. Now remember multiplying fractions, I multiply the numerators, I multiply the denominators. So this becomes 20 over 6, which I can simplify to 10/3. Now let's try it with some algebraic expressions. So remember, just think of this as a giant division problem. You keep, change, flip, but first try to simplify, try to add or subtract what you can. So in this first example, we've got our numerator and we have our denominator. Both of these have addition problems in them, so let's try to combine first. In this first numerator, I have an x and a y in my denominator, which means my least common denominator is going to be xy. Well, this first denominator is missing a y, so I'm going to multiply by y over y. My second denominator is missing an x, so I'll multiply by x over x. Now I have y times 1, which is y, plus x times x, which is plus x squared, all over xy. There's my first combined fraction. Now let's look at the denominator. I have 1 over y, and I have 1, which is really 1 over 1. So my least common denominator here is y times 1, which is y. Which means my first fraction's good. My second fraction needs a y, though, so I'll multiply by y over y. Then I have 1 over y plus y over y. Since they have the same denominator, I can combine them. So on the top, I still have the y plus x squared over xy. And now in my bottom, I have 1 plus y over y. Now that I have one fraction over another fraction, I'm able to keep, change, flip. So now, keep, change, flip, we have y plus x squared over xy times y over 1 plus y. And I'm going to look to see if there's anything I can cancel. Notice I can cross cancel this y with this y, and I end up with y plus x squared. Remember these parentheses, all over x times y plus 1 plus y, which I'll distribute to end up with y plus x squared over x plus xy. So these problems can seem really, really complicated, but just try to focus in on simplifying numerator, simplifying denominator, and then finally keep change flip. Let's look at this next example. In this example, my numerator is just x, and my denominator has two fractions being added together. 1 over x plus 1 over y. Well, in the denominator, my least common denominator will be multiplying the two, so xy. Now I look, what is this first fraction missing? It just has an x in the denominator, so I need to multiply by y over y. My second fraction is missing an x, so I need to multiply by x over x. Now, my numerator is still just an x. My denominator is y over xy plus x over xy. Notice now I can combine the denominator. So I can make this x over y plus x over xy. Now I'm going to keep change flip. Notice my first denominator is just an x, so it's really like an x over 1. You can always write something over 1. So when I keep change flip, I have x over 1, I keep it the same, and I flip the second fraction. Now I'm going to multiply numerators, multiply denominators. I have x times xy over 1 times y plus x. Lastly, I can multiply x times x as x squared times y over y plus x. All right, we have one more. We saved the best for last. This one has a lot going on. We've got a numerator with two fractions. We've got a denominator with two fractions. In our numerator, the LCD, let's figure it out. If we have an x and an x plus 1, we would say x times x plus 1. And in our denominator, the LCD, if we have an x minus 1 and an x plus 1, we'll multiply the two. Now I'm going to multiply each fraction by what it doesn't have. So in the numerator, if I wanted to have x times x plus 1, well, this one just has an x, so I'll multiply by x plus 1 over x plus 1. This next fraction is missing an x, so I'll multiply by x over x. In the denominator, this first one's missing an x plus 1. And the second fraction is missing an x minus 1. So now, let's multiply it out and see what we have. So, in the numerator, we have x plus 1 times x minus 2 all over x plus 1 times x plus 2 times x, which is 2x, all over x plus 1 times x. Notice now those have the same fraction, the same denominator, so I can combine the fractions later. Now in my second fractions in the denominator, I multiply it out, so I get 3 times x plus 1 over x plus 1 times x minus 1 minus, now we have to be careful of that subtraction sign, 1 times x minus 1 all over x plus 1 times x minus 1. Now notice I have common denominators in the numerator and denominator, so I'm going to combine the fractions. So I have x plus 1 times x minus 2 plus 2x all over the same denominator, x plus 1 times x. In the denominator, I have 3 times x plus 1 minus x minus 1 all over x plus 1 times x minus 1. Now, before I flip, I'm going to combine as much as possible. So first I'm going to multiply out. I'm going to FOIL this part. So x squared minus 2x plus 1x will be minus x. Then minus 2 plus 2x all over x plus 1 times x, which is x squared. Maybe we'll keep it like this for now. We'll see why in a minute. Then next up, I have 3x plus 3 because I distributed. Minus x becomes minus x. Minus 1 becomes plus 1 all over x plus 1 times x minus 1. Now again, before we get to keep, change, flip, we're going to combine like terms. So in the numerator, I can combine the 2x in the minus x. So I'll say x squared plus x minus 2 all over x times x plus 1. And that's just the numerator. And in the denominator, I have 2x plus 4 over x plus 1 times x minus 1. Now finally, I get to keep, change, flip. So here's that part where I get to keep, change, flip, because I just have two fractions that are combined as much as possible. So I'm going to say, here's my first fraction. And here's my second fraction, which I'm going to flip. Now I'm going to cancel as much as possible. So, oops, this is just a 2x plus 4. If I'm trying to cancel as much as possible, I can see a lot more if I factor first. So this is where factoring comes into good use again. The x squared plus x plus minus 2 can be factored into x plus 2 times x minus 1. Then I have x times x plus 1. In my second fraction, I have x plus 1 times x minus 1. And in my denominator, I can factor out a 2, so I have 2 times x plus 2. Now we can finally see what we can cancel. I can cancel an x plus 2 and an x plus 2. I can cancel an x plus 1 and an x plus 1. So now, finally, I'm left with x minus 1 times x minus 1 all over 2x. And last up, I'm going to remember to FOIL out this last part. So x squared minus x, which is minus 2x, plus 1, because minus 1 times minus 1 is plus 1, all over 2x.